Okay, so this is actually the chip ultracap. It's short for our reflowable ultracapacitor, the world's first practical reflowable EDLC or ultracapacitor. It's designed for SMD applications, and it survives a RoHS compliant JEDEC standard reflow profile. We actually designed this product initially for solid-state hard drive power loss protection applications. The idea is that today in a solid-state hard drive, about a quarter of the real estate on the board is occupied by usually tantalum capacitors that are needed for onboard energy storage to support the drive on a power loss event, to give it time to move data from RAM to flash. Our device actually can replace the tantalum capacitors, the same tantalum capacitors, just with two of these devices. So a much smaller footprint and a comparable price point for the solution. So we think that this is actually a no-brainer for SSD manufacturers, because it frees up that real estate on the board, which is actually some of the most valuable real estate on the planet, as it turns out. There's a lot of energy in this device. It's a 400 millifarad ultracapacitor. It's 2.3 millimeters thick, so it's specifically designed for SSD applications. It's also very low ESR, so relatively high power, and it's designed for 85 degrees Celsius and 2.1 volts, and very long lifetime. Our business model for this is actually a licensing model, and that's because projected volumes based on our customer feedback have been in the tens to hundreds of millions of units per year. We want to make sure that we get this technology to market quickly, so we are working with major capacitor manufacturers to license the technology. There are about 6 or 7 in the world, and we're working with about 5 or 6 of those major capacitor manufacturers today, doing testing and evaluation and moving toward licensing deals. We expect first production in 2019 from some of our licensees for this chip ultracap. I should also say the chip ultracap is enabled by, I guess you already said. So I should also say that the chip ultracap is enabled by our materials innovations, including the electrode, which is a binderless composite electrode, so it has no polymer binders that would otherwise melt or disintegrate in a solder reflow process, which is a very high temperature process. And also on our electrolyte system, which is a very stable electrolyte and very low vapor pressure, for both good temperature stability in the reflow process, but also in the end use operation, which can be relatively high temperature, but for very long periods of time. And that electrolyte is also very innovative, because not only does it provide good temperature and life performance, but it also provides good electrical performance in terms of capacitance and ESR.
So is this the first one that's reflowable?
It's the first practical reflowable ultracapacitor. So this has been attempted in the past with some sort of serious limitations. In some cases, they have been extremely high ESR ultracapacitors, orders of magnitude higher than this device, which essentially limits the application severely to just a few sort of niche applications. In some cases, the reflowability is very limited. After sort of one reflow cycle, the performance degrades substantially. And then after a second reflow cycle, again, it degrades. And normally the standard in the industry is that you have to survive at least 3 reflow cycles. Our device actually sees little to no variation in performance after even 6 reflow cycles. And the ESR is in the hundreds of milliohms range, or even less than that, which makes it the world's first practical, no excuses ultracapacitor.
And this one you say is AA. Does that mean I could just put it in my microphone, or what is it going to be for? Where would people put this?
All right, so this is actually a high temperature wound cell. This again is our first ever product. So we developed this for 150 degrees C operation, and today it's used in oil and gas downhole drilling applications and also industrial applications. For instance, in oil and gas, when they are below the surface, they see temperatures that can be 100 to 150 degrees Celsius while they're drilling, just from the subterranean environment. And they need this as a pulse power buffer or a backup rechargeable energy storage technology for powering the downhole tool, so to speak, which is an instrumentation and telemetry system that they use to steer the drill bit during the drilling operation. In industrial applications, they're used in things like high temperature sensors, so temperature loggers and things like that, where they need a power source that operates beyond, say, 85 degrees Celsius, where most other energy storage devices fail. Yeah.
Is it allowed to do with backup power? When you talk about the SSD, you don't want it to stop working, it should just work forever? Or?
Yeah.
Yeah, that's correct. So this is mostly for a backup power application. So basically, when there is a power loss event, this will allow basically to deliver the energy that is necessary to move data from the hard drive to the RAM memory. So it's a cache to flash memory. And well, also one other thing that I'd like to add is that this can be reflown, but when we say that, it means that we can do this for like 5 or 6 times in a row, and we don't see any sort of variation in the ESR and also in the capacitance, which is a very important point. So every time that we reflow it, there is no such a variation, which means that it's very compatible with the process.
Are you working with the automotive market or the airplanes and stuff like that?
So currently we are mostly actually working with, let's say, capacitor manufacturers and also with the electronics industry. That's the target for this application. We think that in the future this part could also be applicable in automotive industry, as we're also working on a version of this that can work up to 125 Celsius.